imagine a world without liquid water? The phenomena which describes why water is a liquid or why a dewdrop attaches to a leaf is surface tension. Hello everyone, my name is Nusrat Ahmad and I am master student of Department of Mechanical Engineering at University of Alberta. Surface tension is the attraction between molecules in the surface layer which pulls them together and helps give substance their liquid form. My research involves measurement of surface tension of a liquid in a saturated vapor of another liquid using the pen and drop method. An enclosure, in this case a sealed cuvette, is saturated by leaving an excess of the required volume of saturating liquid inside of it for appropriate time. You may ask how my research is important in daily life. Well, let's consider a simple example like a pipeline which carries liquids like water or oil from one place to another, sometimes intercity. These pipelines are more than often kept hidden, for instance in remote area or underground. A pipeline that large, usually made up of steel, and needs to be coated with paint before planting it in the ground. Now, if that paint interacts with the environment inside the soil, causing the pipeline to rust, it will be very expensive to repaint it underground. It will definitely be helpful if we know beforehand how the paint will interact with the vapors trapped in the soil and make necessary changes accordingly. That is what our research is about. Another example could be machineries inside chemical plants. First of all, experiments were conducted using polar-polar liquid-vapor combination, that is, water and ethanol. As ethanol is very volatile, reaching an equilibrium value of surface tension is very difficult as the drop falls off before attaining stability. Thus, a protocol is developed for measuring surface tension for such cases by conducting experiments with different starting volumes. The validity of experimental procedure is ensured when the case of ethanol drop in water vapor reached similar value, showing a converging result. Based on this result, a generalized relationship is being developed, considering polar-polar and nonpolar components of surface tension values of both liquid and vapor. A graph of completely nonpolar combination is plotted in terms of nonpolar components and molar mass of the chemicals used. Based on experimental data, it can be concluded that no interaction takes place if molar mass of vapor is less than the molar mass of the drop. Also, an increasing trend is observed for equilibrium surface tension plot versus nonpolar component of drop and vapor. We have already got some interesting results and are thinking of expanding it beyond the conventional liquids. Thank you.